Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the quadratic formula. So we've been looking at solving quadratic equations by factorization. Here, this formula gives you a way that you can find the solutions to a quadratic equation pretty easily. So the general form of a quadratic is ax squared plus bx plus c. So when we refer to b's, a's, and c's in here, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So this actually gives you two possible solutions: negative b plus square root of b squared minus 4ac over 2a, or the other one is negative b minus square root of b squared minus 4ac over 2a. Now this part under the square root sign is called the discriminant, b squared minus 4ac, and it determines the number of solutions. If this is negative, there are no solutions because you can't square root a negative. So discriminant less than 0 means there's no solutions. If the discriminant equals 0, if this equals 0, there's one solution. And if this is greater than 0, then there are two solutions. So my advice is always calculate the discriminant first. Firstly, it will tell you if there are any solutions, and secondly, it will make putting this in your calculator so much easier. So let's look at an example. X squared plus 9x plus 25 equals 0. So we can't factorize this. There are no two numbers that multiply to 25 and add to 9. That's why the quadratic formula is helpful. Let's start by calculating the discriminant. So the discriminant is b, so number in front of x squared is b squared minus 4 times a, which is 1 in this case, times c. Now, if you put that in your calculator, you get negative 19. This has a negative discriminant, and so it has no solutions. So by calculating the discriminant here, we know that we needn't go any further. Let's look at this one here. So we could factorize this one using the AC method, but given the large numbers, it's not easy to do at all. Let's instead use the quadratic formula. So we're going to first calculate the discriminant. So the discriminant is b, so in this case b is negative 60, b squared minus 4 times a times c. Calculator, turns out you'll get 0. So because the discriminant here is 0, there will be one solution. What will be that one solution? Well, using the quadratic formula, x equals minus b, so negative 60 becomes positive 60, plus or minus the square root of the discriminant over 2 times a. So there's only one solution because 60 plus 0 and 60 minus 0 are the same. The solution here is 60 over 90, which is 2/3. That's the only solution, and we're done. All right, let's look at another example. So let's try x squared equals 2x plus 4. So as with factorization, we need to have one side equal to 0 in order that we can use the quadratic formula. So every time you're solving a quadratic equation, one side must be equal to 0. If one side's not equal to 0, you make it equal 0. What we're going to do is we're going to subtract 2x from both sides. We're also going to subtract 4 from both sides. So this equation will become x squared minus 2x minus 4 equals 0. We need to have one side equal 0 before we can use the quadratic formula. So now let's use the quadratic formula. Let's first calculate the discriminant. So discriminant is b, so b is negative 2 in this case, b squared minus 4 times a times c. Now if you put that in your calculator, it turns out you get positive 20. So this quadratic equation will have two solutions. Now, this is not a perfect square. 20 is not a perfect square. That means that the two solutions are going to be irrational. What are the two solutions? X equals minus b, minus 2 becomes positive 2, plus or minus the square root of the discriminant over 2 times a. So it turns out it's going to be 2 plus root 20 over 2. That's one solution. And the other solution is 2 minus root 20 over 2. So you might remember root 20 is the same as 2 root 5. So we can actually simplify this. We can go 2 by 2 is 1. 2 root 5 divided by 2 is just root 5. So it turns out the solutions are going to be 1 plus root 5 and 1 minus root 5. All right, let's now look at an example in which we find one of the coefficients. So this one's asking us to find the value of a coefficient given that we know the number of solutions. So we know that this equation here will have no solutions if the discriminant is less than 0. What is the discriminant here? Well, here b, the coefficient of x, is k. So the discriminant is actually b squared minus 4 times a times c. So it's actually k squared minus 256. So this will have no solutions if we have the discriminant less than 0. So that of course means we want k squared to be less than 256. So we've done inequalities like this before. If k squared is less than 256, then k will need to be between negative 16 and positive 16. What about if this has one solution? Well, let's not go through all the working out again. Here we will just have that k squared minus 256, the discriminant is equal to 0. And you know how to solve this because we can factorize it using the difference of two squares. So this will have one solution if k is equal to negative 16 or positive 16. What about for this to have two solutions? Well, let's not go and reinvent the wheel. We know that there are no solutions if k is between negative 16 and 16. We know it has one solution if it equals either of those numbers. So the only other option is if k is greater than 16 or is less than negative 16. We can get this answer just from the other two. So what this all means, if you pick a value of k more than 16, like 20, 2x squared plus 20x plus 32, that will have two solutions. If you have 2x squared plus 16x plus 32, that will have only one solution. And if you pick k between these values, say k equals 10, something like 2x squared plus 10x plus 32 would have no solutions. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.